Question 3. Consider any three consecutive integers, n minus 1, n, and n plus 1. Part A asks, prove that the sum of these three integers is always divisible by 3. Okay, cool. So let's highlight our integers, our three consecutive ones. These guys, and we're going to prove that the sum of these integers is okay. So always divisible by 3. We'll highlight. Okay, and the sum. All right. So first of all, let's go and sum up these integers and see what we find. So the sum is going to be n minus 1 plus n plus n plus 1. Okay, which would be the same as if we just got rid of all the brackets. We don't brackets there are to just show that they're sort of separate integers, but we don't need them, so we can sort of get rid of all of them here. And now we can kind of see that we end up having three positive n's, a negative one, and a positive one. So essentially this negative one and this positive one, they're just going to cancel each other out. And we get this expression equal to 3n, all right? Now, when we divide 3n by 3, we get n, right? And we were told here I can cancel those out as well, cancel the 3's. And so we got 3n divided by 3 is equal to n. And we were also told that at the start they were integers. And so we can sort of conclude, therefore, the sum of three consecutive, let's see if I can fit that in there, consecutive integers is always divisible by 3. Okay, lovely. Yeah, and that would suffice for part A. Okay, moving on to part B. Prove that the sum of the squares of these three integers, so let's take away, first we'll take sum of the squares of these three integers is never divisible by 3. Never divisible by 3. Okay, all right. So first of all, we're going to have to, find the sum of these squares. All right, so this is going to be n minus 1 squared plus n squared plus n plus 1 squared. Right, now I'm going to go off into a bit of a tangent here and just talk about these n minus 1 squared and n plus 1 squared. It's quite a common error to just square the two terms that are within the brackets. So you go n squared, and then negative 1 squared would be 1, so just call it n squared plus 1. And unfortunately, that would be wrong. Okay, so the best way to attack these questions is to write out the bracket twice. And so that's going to be n minus 1 squared. Okay, and now if we do that, what have I done? We're going to get, this is going to be equal to n squared minus 2n, all right, then plus 1. Okay, and then equally, if we do that for n plus 1 squared, that's going to equal n plus 1 multiplied by n plus 1. And now if we expand out these brackets, we're going to get n squared plus 2n plus 1. Okay, cool. Now let's put these on the side there, yeah. All right, so now if we go and add all these up, the expressions that we've got n squared minus 2n plus 1 plus n squared plus n squared plus 2n plus 1. Okay, so if we go through here, we can see that this negative 2n is going to basically cancel out this positive 2n at the far end down there. And so we have n squared here, n squared here, n squared here. Okay, so they're all going to add up together to give us 3n squared. And this one is going to add onto this one here and give us plus 2. All right, so the sum of the squares are equal to 3n squared plus 2. And what I'm going to do is let's bring it down this first line and show that. Okay, so therefore, we'll put a little therefore sign on the left-hand side here. The sum of the squares come to this. Now, when we go about dividing this expression here, 3n squared by 3, we end up getting this. So 3n squared plus 2 divided by 3 is the same as writing 3n squared divided by 3 plus 2/3. And so once again, we can cancel out these 3's here and we get n squared plus 2/3. All right, and so we've shown that when we divide the sum of these squares here, we are left with when we add the sum of the squares here and then divide it by 3, we are left with n squared plus 2/3, all right, which will never be an integer. And so we can go on and say, therefore, n squared is always an integer. And 2/3 is not. Hence, the sum of the squares is never divisible by 3. All right, and then that is our answer to question 3. Beg your pardon, question 3.